Today we'll be kind of talking through some of the challenges and techniques that we've seen kind of used across the industry as it relates to kind of IT and scientists and IT working together when it comes to sort of automation, as well as as our deployments with our Green Button Go scheduler software, which I'll talk through a little bit as well. But quick introductions. So my name is Darren Pittman. I know I do not look anything like that picture at this point, but I swear it's me. I've been with Biosero for coming up on about 3 years now. I've been a part of the applications team at Biosero pretty much for that entire duration, but I've worked on kind of both the pre-sales side of our process. So obviously, when you're doing automation solutions at the magnitude of some of them that we do, there's a pretty lengthy sort of pre-sales scoping and evaluation period as a part of that. So I've worked on that team as well as the deployment team. And then now I actually manage the pre-sales side of or the pre-sales team here at Biosero. And kind of my technical background is a mixture of informatics and clinical diagnostic testing. So a little bit of a mixed bag there. And John, do you want to? I don't want to introduce you.
Yeah, hi, I'm John Canty. I've been working with Biosero for about 2.5 years now. Come from general industry into the life sciences market back in 2013 timeframe. Worked with a few of the other scheduler manufacturers as well. I started as a technical trainer, and then as we started going through and having conversations with our customers about our integrations, I found I was a good translator between software engineering and IT. So that put me squarely into the position to start talking with our customers' IT departments and our internal software folks to help kind of alleviate some of those communication differences. So. Pass it back to Darren.
Absolutely. So to kind of kick things off here, the problem that I think a lot of the industry as a whole has really ran into, and the reason why automation exists, the reason why conferences like this exist, is to address this problem of discovering drugs, cures, therapies, and diagnostics takes longer and costs more than it should. Manual processes create bottlenecks, inefficiencies, and variabilities that you otherwise won't see in an automated environment. And so some of the historical causes is that obviously, when a human performs a task, there's sort of that inherent variability as to how they perform that task. And also in the case of some particularly time-sensitive applications and assays, ELISA, cell culture, even things like chemical synthesis, any variability in that timing, any variability in that process can cost you an entire sample batch. It can cost you thousands of dollars in reagents, just to a small variance in time. And then you also, from a human perspective, you have to have someone available in the lab at all times, effectively, to sort of cover that assay's needs. And also the data, which is going to be sort of the latter half of this presentation. Even the best of lab technicians do not always perfectly enter data into the ELN. I'm familiar with that concept. I know even sometimes you just miss something, and the data that you're gathering from the lab is coming in from a multitude of sources. Some of it's coming from the instruments, some of it's coming from process analytics that the users are manually putting in and things like that. And so you kind of have this challenge of aggregating all of that in various locations. And then ultimately, as you kind of look to the top of kind of a lab infrastructure, the data that's generated out of the lab isn't always useful when it comes to kind of the almost like business analytics of running a lab from a director sort of perspective, as far as making cases and things for CapEx and other sort of budgeting purposes. So these are some of the sort of historical causes of why things ultimately cost more and take longer than they really should. And so, obviously we're all here to kind of talk about automation, but I think a lot of us would probably agree that problem isn't completely solved at this point. And why is that not completely solved yet? It's too inflexible. So, things change in the lab, the assays change, and the automation doesn't necessarily support that. In some cases, it's too time-consuming to sort of set things up, and so the ROI either takes too long to come around, or the cost of sort of getting things set up or changing things is too high. So all these sorts of things sort of lead to why we're still having this conversation today. Why we wouldn't, I think most would probably agree, automation is not like a solved problem by any means. And so the solution, at least as far as we're concerned, is lab automation with a process-centric, hardware-agnostic sort of approach that's designed for scientists, for those end users in the lab. That isn't sort of predicated on any particular process type, any particular assay or hardware type, or even a data endpoint, which again we'll sort of talk about here shortly. So here at Biosero, one of the things that we do provide is obviously we do have our scheduling software that I've mentioned, but we also have we do full integrations of these hardware solutions. So we do have actually a separate sort of team, our integrations team, that works exclusively on kind of our hardware deployments. But we also have a software team that works on the core software as well as unique device drivers. So I think currently we're a little over 400 drivers in the library, and that ranges from a variety of robotic arms to mobile robots to readers and centrifuges and all the sort of different pieces of hardware that you would see scattered around a lab. And we're constantly sort of adding to that at customers and projects request. So Biosero, just a quick top down here. So Biosero has over 500 customers across the world. The company actually was founded back in 2003. But we work in a variety of different market segments. So I know at least at this conference it's a lot of pharmaceutical, but we do work also in the clinical diag space, academia, agri-science, and even some of the government sectors, both in the U.S. and over here in Europe. And then we do also have sort of the application spaces listed out here down below, most of which are going to fall kind of into those market segments. And then ultimately, one of the things that Biosero has really started to target as a part of that solution for some of those key problems as to why automation isn't sort of solved. I mentioned data a fair bit, and so lab orchestration, as far as we sort of see it, is the management of workflows by harmonizing processes, people, data. That's a big one. Business rules and materials to achieve the desired results. So historically, automation has always been sort of viewed as you have an individual work cell that's sort of designed to perform one particular task, and maybe it's a little bit flexible, maybe it can do a couple of them, but ultimately you still have these sort of disparate processes that are spread out to sort of accomplish what the overall lab's goal is. So as far as Biosero sees it, scientists at this point really want a solution that goes beyond the integrated workstation. They really want the capability to capture and harmonize that data from all of those different work streams into one singular location. So again, you're not sort of chasing loose ends as far as data coming in around the lab. And then also the ability to streamline tasks across all of those different work cells or different stations where a particular task is being performed. Following the flow of samples, reagents, and other things with the data. That's sort of, again, kind of one of the key components. And we accomplish some of this with our orchestrator sort of suite of products. So these are sort of the breakout of the different applications. The first one, and it is first in the top left on this list on purpose, is data services. It's kind of the heart of all of our different orchestrator applications. Ultimately, data services is a cloud-based or on-prem application that houses all data from effectively any different, any system you have in the lab. So this is, it could be internal data systems, i.e. an instrument that's outputting data that we need to then effectively grab and put into data services and house, or it could be external data systems. So we also use data services as a touch point into your, what could be your current on-prem LIMS system, ELN system, otherwise, to sort of aggregate and then share outward from there. Insights dashboard takes some of that data and puts it into a more digestible, readable format. So this gives you kind of like a a cockpit to look at everything that's going on in the lab, all the different systems, kind of keep an eye on things from one singular location. Green Button Go Scheduler is our core scheduling software. It's been around for quite a while. This actually sits at the work cell level, and this is what actually communicates with individual instruments. Workflow Designer is our application that allows you to build workflows that may span multiple systems. So if you have 10 systems in a lab and they're all sort of working together to accomplish one larger assay, Workflow Designer allows you to kind of build that out and orchestrate the flow of that material across multiple systems. Workflow Conductor is kind of the engine in the background of Workflow Designer. This is what actually kicks off data out of our data services into the scheduler instances themselves that sit at the work cell level. So this is sort of the brain that sits behind making things happen on the Workflow Designer's directions. Transportation Manager, as anyone who's seen some of our wonderful marketing material will see, kind of like Magna Motion Tracks and X-Planer and mobile robots and things. All of these are different mechanisms by which we transport material around a lab. And Transportation Manager is kind of the heart of making the decisions as to what to do whenever I say, take material A from here and put it there. And you may have multiple pathways by which that could happen. So Transportation Manager does a lot of that. Lab Experience is a product that is sort of custom built, like almost digital SOP kind of tool. So what we sort of observed as one of those challenges that I mentioned earlier was the scientists felt that it was a little too difficult to approach what may be going on the automation. Lab Experience is a tool where we can actually build screens that are typically running on like an iPad effectively, so that a user can walk around with this iPad and interact with various different systems, all from one relatively easy to use interface. So this is a tool that we've seen some use to sort of bridge some of that gap for some labs where automation maybe hasn't been around for a particularly long time. And then finally, the instrument agents. This is where we can either gather information from standalone instruments. So if you think, what's the most expensive analytical instrument currently sitting in your lab that there's no way you would ever allocate that entirely to an automation process? Instrument agents are kind of our bridge to still be able to use those instruments potentially in the automation, or just even gathering the data from that instrument so that it can inform the rest of the process. So we do see some deployments where, again, it's that really expensive piece of equipment that you don't want to allocate entirely to your automation because you may only have one. As I mentioned, the paradigm is sort of changing. More automation, more connectivity, and more flexibility. Ultimately, the asks that we, as the people that are sort of deploying automation now, the ask that we have is sort of growing every day. The systems are getting more complex. Looking more sort of like this, where it's a multitude of systems that all need to work together to perform that larger task. And this, as far as we've sort of seen it, is more in this full lab orchestration environment, where we have basically hands off from the user, but the data that's generated from one station to the next actually informs what's going to happen in the next one. So I'm gonna pass it over to John here, and he's gonna talk a little bit more about, again, that data that exists inside of that larger lab orchestrated environment.
So yeah, the slide says the problem. I guarantee you I'm not the problem. But yeah, actually this is really the first thing that we start looking at is what is it that you want out of your process? What is it you want out of your data? What is it that you want out of your systems? And effectively, I like to use if you cannot explain it like a 5-year-old can understand it, then you probably don't understand it really well yourself. And that's what this boils down to is we want to make sure that we're not leaving all the details to firefighting later in the process. Effectively, a lot of people are coming to us, and a lot of you are probably doing the same, where you're doing something that's never been done before. And when you're on that bleeding edge of science, something is going to be, it's going to be misunderstood, not fully understood. It's going to be difficult to work with. So I stole a quote from a much smarter person than I am, Albert Einstein, and effectively he says, if you can't explain it simply, then you don't understand it well enough. So this is a more a nice way of saying it, but this is really what we're looking to do. How do we get all of the proper people involved in the process before the process kind of takes its own path and gets away from us a little bit? So the big thing that we've got here is, and this may not have been actually straight up articulated by people, but it's often felt that IT sort of gets in the way of getting processes done. IT has security procedures, endpoint protection, stuff that sometimes interferes. Windows updates. I mean, how many people have had a computer reboot in the middle of the night during a run because of a Windows update? And of course, it's very easy to blame your IT department. And ultimately, these things are all adjustable. The IT department starts with a base level line and says this is what needs to happen. But if you find that your system's running in the middle of the night all the time, well, you can set your functional hours to be the middle of the night versus versus the middle of the day, and that way there your reboots will happen in the middle of the day where somebody's around to attend to those. So effectively, what happens is we end up with multiple different types of systems. Customers will come to us and say, we want to integrate a simple work cell, and we don't want our IT department fully involved in it. So what they'll do is create an isolated system. Sometimes this is the IT departments have processes and procedures in place, and they'll place all of these devices of the whole system onto what they call level 0 of a Purdue diagram. And that, well, while we're at it, I'll just click to the next slide. So that sort of looks like this. And that level 0 of the Purdue diagram, effectively nothing there has internet connectivity. And honestly, when you look at this diagram, the things that require a login or have an operating system don't really belong on level 0. That's where your sensors and things of that should be. But what this does is this takes a system and completely separates it away from your corporate LAN. And when it's separated from your corporate LAN, your scientist is sitting up at level 4 saying, hey, I need my data, and all your data is sitting down at level 0. So that involves grabbing a USB drive and running over to that system and pulling that data. That's an error-prone process. It's something somebody could grab the wrong data. The USB drive could be found in the parking lot somewhere and have a virus on it. Who knows? Like, it's one of those things that could be a problem. So this worked really well for the older systems, and people still use it, relatively frequently, even today. But what we're seeing is people do need more ready access to that data. So what we find is that they go into this method of complex data retrieval. So the system's still sitting at level 0, but you have multiple levels of a remote desktop inception trying to get to it. So you end up remote desktoping into another level, then from there to a third level in order to get into the actual data itself. Again, it's error prone. And if you like the quote, that's from 1986, Andrew Tenenbaum, he put that into a Usenet group. So effectively what he's describing is something very similar to what was called SneakerNet. Effectively you could pick up a bunch of tapes, throw them into the back of a car, send them down to another location and unload them. And you'll find that if you do that with a big enough amount of data, it actually becomes faster than moving it across the wire. It was a funny quote, so I had to add it. But yeah, this really does cause some level of complexity. When you get the human involved in moving the data back and forth and it's not automated, this does actually give you an opportunity to induce an error, and that induced error is actually something that we're all trying to avoid. So this comes down to making your IT department happy, or everybody in IT happy. It doesn't necessarily have to be just your IT department. So the thing here that we want to sort of drive home is bring your IT department in early. They're going to tell you that certain things shouldn't be done a certain way, or they're going to give you other options for doing things. And effectively, what you're really trying to do is get them to sell you on a better way of doing it. So you have an idea of how you expect the system to work, and you have an idea of how you want to get the data, and you know roughly where it should go. The other part that they're going to be able to bring into this is, let's say you've got like an analytical system. Your analytical system may generate 50 gigs of data every time it runs. What are you going to do with that data? Oftentimes, the computers that generate that data have a pretty large storage space to store it. But after you fill that up, where does it go? How long do you want to keep it? So in that particular case, your IT department's going to be able to help you out. Hey, look, you want to take that data? We can move it off to the cloud, store it, back it up, that kind of thing. So when you're presented with for lack of a better term, any kind of roadblock that is preventing you from doing things exactly the way that you want to do it, don't be so sure of what you want that you won't take something better, right? So ask your IT department to sell you on it. So, hey, look, I see we have to do this differently, but sell me on this. I don't want to know about the security. I want to know about the end user's point of view. What's their story? How is this better? So when you do get the buy-in from IT and you do build out a system, this is often what we end up seeing at customer sites. This is a pretty simplified diagram, and effectively we'll see data services, whether it be on-prem or in the cloud. And we'll see that be linked directly into the corporate network through VPCs or VNets. All this stuff actually behaves just like it's sitting right there, right next to you, but it's on Microsoft or AWS's servers. So you can rely on them for a certain level of dependability. The other thing that you'll see is the end user, the scientist who is trying to get to that data, has a pretty seamless access to it. So if they want to pull it up directly from their laptop, pull up a Grafana dashboard and query that data, they can do that. That's really the big thing that we're trying to push forward with is being able to get people to have access to that data that they really want. It's much better than going and grab an old USB drive and find out whether or not you can get it. So what is that data? What does that look like? So this here is actually, it's a pretty standard slide. We might have seen this a couple times if you've seen some of our demonstrations in the past. But this one's actually a really good one because what you're looking at here is all your data. What kind of data can you get? And then what do you want to do with that data? And often what you want to do with that data may not necessarily happen in an area where you have control. So you have to pass that data from your systems onto systems controlled by your IT department, and then maybe further onto systems controlled by a third party. And that gets you to that point where once you start passing that data back and forth, you do need to keep it somewhat secure, and you need to do it in such a way that it's repeatable, and you can later chase through the custody of that data if you need to. So that kind of brings us to this next slide, which is when you have that data, if you just have the data and the data's all by itself, it has little value. You need some kind of context to it. What other data can you bring in? And that's where data services kind of helps with that, because we pull in multiple bits of data. So you're not just taking, let's say, the temperature of something, but you're also taking other information. What is the temperature? What's it from? What are the other outstanding conditions that are around it? Do you have humidity with it? So forth, so on. And then as we move forward into the future, we're all going to be applying some AI to this. So at some point in time, you're probably going to see something like, hey, this data says I need to push off a service call to the vendor or something to that nature. So this kind of brings you to hey, we've got some problems. We know there's some solutions. And when you get to those, when you want to get to those solutions, what are those solutions? And that's where we start preparing, right? So how do we prepare? Number one, know your data, right? So you know you're going to be bringing some systems in. Look at them critically. What kind of data are you going to be presenting? Give everyone that's going to have some stake in that data, give them an understanding of what the data consists of, what file formats, how large, how often, how long do you want to keep it, that kind of thing. Make a couple decisions. How much control do you want over this? Do you want to take on the responsibility of disaster recovery and security? If you do, then you can very easily keep something like that in a very small system and keep it isolated. But oftentimes, the disaster recovery security part is not something the scientist directly wants to take over, and for good reason. There's a group of people sitting in the IT department that can take care of that for you. So in that case, again, getting them in early. Responsibility for troubleshooting, and this is sometimes where the contention comes in, where if you have a problem with your system, you don't want to go calling your IT department. So this is one of those things where having some procedures and set up ahead of time and working with your vendor can kind of help get some of that alleviated. There's been conversations we've had in the past with customers' IT departments where we say, hey, at what point do we need to hand this over to you? Can we figure out what that point is? Is there some procedures you can pass along to your scientists that can do some direct troubleshooting? If they do have some leniency there, then you have a really good situation you're in. We can now see how we can get more of that control into your hands. Vendor assistance, and again, when you're looking at automation, you're probably looking at more than one vendor, right? So just work with your vendor, find out, hey, are they interested in working with your IT department? Because oftentimes you'll find that when you're asking your IT department for something, you're explaining it in the words you best know to describe them. But when they're hearing it, they don't necessarily understand exactly what you're looking for. So to be able to find a vendor who's got a good intermediary that can actually help translate that into the IT language, it does help quite a bit. Oftentimes I've found conversations that always got to a point where it almost seemed like it was going to be a little bit contentious. You quickly get to a point where you're like, what are they saying? How do I understand what they're saying? Sometimes you're both saying the same thing, right? It doesn't. You're not understanding it the same way though. So that's where your vendor can help. And then this again comes back to the old advice: know what you want, but also just allow your IT department to sell you on something better. That it really is. It's a really great way. It doesn't necessarily mean the solution that they provide will always be better, but give them at least the opportunity. Walk into it with a bit of an open mind. So this here is one of the things that we work with quite a bit. Is we're going to kind of outline a couple of the problems that you may potentially run into. And one of them is with like third-party plugins or LIMS systems or ELNs, things of that nature. One of the questions we often get is, hey, have you worked with XYZ LIMS system, XYZ ELN? And good chance the answer is yes, right? Sometimes when people hear that yes, it immediately triggers in their mind, okay, plug and play, let's go, and off we go. The problem is everything may be exactly the same, but your data may be different, and that the data is handled differently, and it goes to different places. The routing of that data may be completely off scale from the situation that we've run into before. So that answer of yes it's tenuous. It's always tenuous. We've worked with it. We definitely will work with it in the future. We can help you out. But there's a lot of things that go behind it. Some of that's business rules that are involved with your individual corporation. And when it comes to developing those business rules, it really does help to at least co-develop with your vendor on those things. But ultimately, if you can take a lot of the control of that and develop primarily, and then use your vendor as backup, that will help you out quite a bit. It gives you two kind of really good points to stand from. The first is the system as it was developed, so you clearly understand every aspect of it. You have a good mental model of it. The other thing is, now that you know this and now that you've built it up, if you need to make changes or you need to do any kind of troubleshooting, it happens like that. It's very quick. And because you're automatically working through it in your head. There's no translation of the problem between you and your vendor to get that done, and there's no translation between the vendor understanding your problem and trying to figure out where that is in the code. So definitely work with your vendor on this. We do this a lot with customers. A customer will hand us their business rules, and we will turn that into software for them without any complaints. But the big thing here is, if you can, definitely try to get involved with that. It's going to help you out quite a bit. Another good example of this is we did do one GBG plugin. GBG, the plugin was actually sending some reader data off to a third party. The third party did some number crunching on that and then sent it back as results. And one of the things that we ran into is we needed a VPN connection between our site and theirs in order to allow this, or at the very least, they needed to set our IP address as a friendly IP address so that we could go in. So that was the initial step, and then the second step was actually to set up the VPN. And that kind of stuff does actually take some time. So the faster you get your IT department in, the faster you get them aware of the situation, the less likely that is to be something that goes really bad the day you turn on the key and tell it to go. It'll all be working that as fast as you possibly can. So brings us to a couple more things that we can do, and this is actually something that we have started working with as a software vendor, but also this is something that we can give you as a customer is the API that is presented to you and that's sometimes presented to us. We perform a factory or site acceptance test on it. So we're given API manuals, and we want to test those API manuals, and it's done formally. There's a actual procedure that we go through. Hey, this is how we get our session token. Let's try it. Can we get a session token? Oh, look, we've got a session token. Good, we passed that. Those kind of things. These things will help you out quite a bit. The reason we started doing this is we actually ran into problems where we were halfway through the development of something and an aspect of the API didn't work as it was written in the document. And it's kind of crazy, but it does happen quite a bit. And oftentimes those catches will actually cause whomever wrote the API documentation to actually rewrite those portions so that they make a little bit more sense, or they're more accurate to what's going on. So this is definitely something that is going to really help you out. And this works for everything from like REST APIs or TCP connections right down to file drops and things of that nature. So if you're going to be interfacing with another piece of software and you're given an API, definitely do some testing. Same thing with your hardware. So again, as a vendor, when we provide the hardware, we'll actually do a lot of testing of that, and that will alleviate that. We do an individual hardware test. This follows through all the way not only to your small integration tasks and things of that nature, but your IT department. So if your IT department says, hey, this is how you get a file from here to there, test that. Create a document to test it and make sure it all works. These things can often be simulated directly from a computer plugged into the right part of the network. Sometimes it's as simple as just moving your computer to a different area. You connect to a new Wi-Fi access point. You're now on a different section of the network, and now see if you can move that file to the place that you're actually interested in moving it. And the other thing is we've got the option of doing file drops. So if you do have options for your, and this really kind of talks about all of your API options when it comes to working with any software or any integration. Test all of them. Use the file drop, see if that works. It's oftentimes considered like a very rudimentary or a basic way of doing things. But if it works, it at least gives you a backup plan so that when you drive forward into your new solutions, you can actually start, you feel confident knowing that you have something to fall back on if you need it. And with that, if anybody has any questions, I guess we can open up to that.